Okay, we're going to go to Unit 2C, Section 4A, Elimination using Adding and Subtracting. We're still doing the same thing. We're trying to find a solution to a set of equations where the two lines cross, an ordered pair. Elimination, write this down, is useful for solving a system of equations when neither equation has been solved for x or y. Okay? So when substitution doesn't seem like the best choice, a lot of times elimination will be the choice. The whole point is to eliminate an x or a y. Now we're going to start with just adding and subtracting. So let's look at some examples here. And I know that some of you have already done this in middle school. So pay close attention, make sure you're understanding here. Okay, so we have 4x plus 6y equals 32. And 3x minus 6y equals 3. Again, we're trying to find, if we were to graph these two equations, exactly where they would cross. At what point would these two equations cross? We could solve for y, and we could graph them and hope they're whole numbers. We could solve for y and substitute in, or we could try to eliminate. In order to eliminate an x or a y, they have to have the same coefficient, which means the same number attached to them, except they have to have opposite signs. So if you look at the y's, the y has a positive 6 in the first equation and a negative 6 in the second equation. Well, we can add these two equations together because we're really adding the same thing to both sides. Okay? So we can go 4x plus 3x, that's a 7x. Here's what's being eliminated. 6y minus 6y is 0. Well, 0 times y is 0, so these are eliminated. And 32 plus 3 is 35. Now we're down to one variable, so we can just solve this. Divide both sides by 7, and x equals 5. But again, remember, if you only stop there, you've only solved half the problem. I don't know where the lines cross if you tell me x equals 5. You have to figure out y also. So you've got to take one of the equations from the top. So I'm going to take 4x plus 6y. It doesn't matter which one. You can use either one, equals 32. Be very careful. I have been known to make this mistake. Go back and check. What did I solve for? I solved for x. So that's where I'm putting my mathematical blank, where the x is. And then we're going to solve over here for y. What did we figure out that x was? We figured out x was 5. So we're going to put 5 in a mathematical blank. And so now we have 20 plus 6y equals 32. Now it's time to solve. If we're solving, we do opposite operations. Always take care of the addition or subtraction first. So we're going to subtract 20 from both sides. 6y equals 12. Divide by 6. And so y equals 2. Remember what we were looking for. Where do these two lines cross? If we were to graph these two lines, they would cross at 5, 2. They would cross in the first quadrant. Okay, let's try another one. All right. Example 2. Negative 4x plus 3y equals negative 3. And 4x minus 5y equals 5. Does one of the variables, x or y, have a coefficients that are the same but opposite signs, which means they're opposites? We do. If we were just to add these together, the x's would eliminate. So negative 4 and positive 4 eliminate. Then we go 3 minus 5 is negative 2y, and negative 3 plus 5 is 2. Divide both sides by 2. Whoop, not 2, negative 2, my mistake, so it should be y equals negative 1. Okay, we're not done. We need to solve again, and we need to solve for the x. So it doesn't matter which one you pick. This time I'm going to pick the second one. 4x minus 5y equals 5. I go back and I double check. What did I solve for? I already know what y is. So 4x stays this time. The x stays. And the y becomes a blank. And in there, we put the -1. And then we finish solving this. So we have 4x, -5 times -1 is +5 equals 5. Now here's one that I did this kind of on purpose because people kind of get freaked out with this. Watch what happens. What's 5 minus 5? 0. I can't tell you how often people get that and they're like, I did something wrong. What did I do wrong? You didn't do anything wrong. 0 is a number. It can happen. We divide both sides by 4. 0 divided by 4 is 0. So we know these two lines cross at x equals 0 and y equals -1. Okay, let's try another one. What if we had 4y plus 3x equals 22 and -3x minus 4y equals 14. Well, the first thing I hope you notice is the top one, the x and the y's are reversed. So you can't just add them. We're going to have to reorder them. As long as you keep the signs in front. So 3x is positive, 4y is positive. So I'm just going to rewrite it because addition is commutative, which means we can change the order. So it doesn't change the value if we change the order in an addition problem. So I rewrote this so that x would come first. This one I can leave alone because the x and the y's are in the right place, and now I can line them up easier. I just did that so I could line them up easier. Well, look what happens here. 3x and -3x go away, 4y and -4y go away. And we talked about this the other day when we did last week when we did a Kahoot. And this would give us 0 equals 36. Is that a true statement? If it's not a true statement, then there is no solution. These two don't cross. So what do we know about them if there are no solutions? They're parallel lines. These are parallel lines, so they will never cross. And that's why there's no solution. Okay? Let's do one more of the special type. I just wanted to do a couple of special type with you. So we have 4x minus 2y equals 10, and -4x plus 2y equals -10. Well, watch what happens when I add these up. These go away, these go away, these go away. So we really have 0 equals 0. Again, is that a true statement? Yes, this is true. So this means infinite solutions. What does it mean if there's infinite solutions? If we're talking about a graph, what does it mean when two lines have infinite solutions? It means they're the same line. So these are actually the same line. The negatives were just reversed. If we divided the top one by negative or the bottom by negative, it would have matched the other one. So there's some special cases. And then the rest are just, and I'm just checking the homework. I don't see anything on the homework. Nope. Everything on the homework, again, is whole numbers. So if you're getting anything besides an integer, whole numbers, they're opposite in 0. If you're getting a fraction or decimal, you did something wrong. And these will eliminate just by adding two of them together. You may have to change a sign here or there, a negative or a positive, and you know how to do that. Divide through by -1 if you need to. Okay? So try those, and we will continue with this with the next lesson.